Okay. I think we are recording again. Come on, I just want to see the window to verify. Come on. Okay. Well, hopefully this works out. I don't think it's as important for this class to record as maybe other classes, so I think it's working, but I'm not 100% sure. Of course, as statisticians, you never need to be 100% sure, only 95% confident. Okay, so any other comments before we move on? Let's move on. So let's finish up talking about the professional societies. So we talked about the American Statistical Association already. It's the big one, the biggest one, I should say. Now we're going to talk about the International Biometric Society and the International Statistical Institute. Combined together, these two basically have the same goals as the American Statistical Association, except for on an international scale. So while the ASA does do international stuff, but the primary purpose is statistics in the United States, where these two professional societies, the United States is just one of many countries that they're interested in. And the International Statistical Institute was the one that was first formed of these two. It was formed in 1885, and originally their purpose was dealing with government statistics, official statistics. And then shortly after World War II, they decided they wanted to broaden their focus. But some people who were interested in biostatistics or biometry or biometrics, wherever you want to call it, were not necessarily satisfied with what the International Statistical Institute was doing in broadening its focus towards their area. So they decided to form their own professional society called the International Biometric Society. And so that's how we ended up with these two. So let's talk about IBS. I'm not talking about irritable bowel syndrome here. I'm talking about the International Biometric Society. Please be careful when you do a web search for IBS. You will often not get there. You need the full name. That is the actual address for this professional society, and I think it's good just to read over, directly from their website what the society is about. They are an international society promoting the development and application of statistical and mathematical theory and methods in the biosciences, including agriculture, biomedical science and public health, ecology, environmental sciences, forestry, and allied disciplines. This is very similar to what we saw with the biometric section of the ASA. Very similar. And one reason why I like to read this is that this tells you all what biostatistics and biometrics is. It's this kind of applying statistics, forwarding statistical methods in these particular areas. There are approximately 6,000 members of this society. Obviously with ASA there's 20,000, so this is a lot less, but still 6,000 is a good amount, especially when you take into account the number of members also in the ISI. Approximately 75% of these members are outside the US and Canada. So, that's a large amount. Now, the way that IBS is organized is that similar to how the ASA had chapters, in terms of the Nebraska chapter of the ASA, the Washington chapter of the ASA. Well, they have regions. There are two regions that are in the United States. The Eastern North American region, or what we often refer to as ENAR for short, and the Western North American region, which we often call WENAR for short. Not WNAR, but WENAR. And the dividing line is the 104-degree west longitude line. That basically roughly goes through the western border of Nebraska. So we are in ENAR. And by far, this is the largest region of IBS. There are about 1,300 members. So you can see that's a huge proportion of the membership. The next largest is the German region, which has about 900 members. WENAR is quite a bit smaller. It has about 200 members only. I don't know, that really surprises me that that occurs. I think one reason is because the largest profession for people who are members of ENAR, the largest profession is pharmaceutical companies. Pharmaceutical companies themselves are mostly on the East Coast. And so that's why they have so many people over there, where on the West Coast you don't see that as much. And so you're getting a lot of the WENAR people being in these other areas of biometrics, in addition to not just the biomedical sciences and public health, which would be the pharmaceutical people. So they have a number of publications. The main publication is Biometrics, and again, that's one of the 5 top-tier journals in statistics. They do have a quarterly magazine, you could say, similar to Amstat News, which is often interesting what they talk about in there. Biometrical Journal is another publication of IBS, but it's actually put out by the German and Austria and Switzerland regions. I have published in this journal a number of times. Often I've followed this in my past history, where if I submit it to Biometrics a paper, and if it doesn't get published, I submit it to Biometrical Journal because I have a higher probability of acceptance, because this is not a top-tier journal. It's still a very good journal, but it's not as high. Then there's also the Journal of Agricultural, Biological, Environmental Statistics. So basically everything in biostatistics or biometrics except for stuff dealing with medical applications, like what the pharmaceutical industry would be interested in. This was started about 20 years ago, and in fact, where I went to school, Kansas State University, was heavily involved with starting this particular journal, and the first editor of that journal was Dallas Johnson, who was a former department head for Kansas State University. And this was, again, all occurring. This was forming, this journal came about when I was a student. So the main office is actually in the U.S. It's in Washington, D.C. And just like with the ASA, although we didn't talk about it much, IBS offers a substantial discount off their membership fee for students. Do note that dues are paid on the calendar year. So I will be paying my dues because I'm a member within the next few months. Then the International Statistical Institute. This is a much smaller presence in the United States. I mean, I think just looking at members in Nebraska once a number of years ago when I did this, and there was very few that are members of the ISI. I used to be a member. I am not a member anymore. I at one time was a member of 4 different statistical associations, and a few years ago I decided, okay, I want to save some of that money. I have 2 kids that I need to pay for their daycare and do other stuff with, so I decided that, okay, I'm going to scale back my memberships, and now I'm just a member of IBS and ASA. Now, the ISI, again, is basically just like the ASA in terms of their goals, except for the biometrics part. But given the history of the ISI, in terms of originally being for government statistics, there's still a strong emphasis on government statistics in the ISI. It has about 4,500 members. Now, similar to how the ASA has sections, like the biometrics section, the statistics education section, and so on, the way that the ISI is organized is by essentially sections as well, but they call them associations. So, for example, when I was a member of the ISI, I was a member of the International Association for Statistical Computing and also the one for Statistical Education. Okay. They do publish some of their own journals. These the ISI publishes journals, and then these associations often publish their own journals. 2 good ones are the Computational Statistics and Data Analysis Journal. Often when I look at an issue of that, I will always I shouldn't say often, I will always find something I'm interested in. And also the Statistics Education Research Journal, for those of you who are interested in Stat Ed. That's a decent one, although I don't think it's as good as the Journal of Statistics Education published by the ASA. In terms of the ISI itself, publications, the International Statistical Review. And as you might imagine from that name there, they give general overviews or reviews of particular areas of statistics. And so because of that, this is often a nice a journal to read if you're unfamiliar with a particular area. This journal is really interesting stat. This is a fairly new journal. I have not tried to publish in it yet, but I have an interest in doing that. So in statistics itself, the discipline, we have lots of journals. The typical time frame of submitting a paper for publication and eventually getting it published is that you submit the paper to a journal. It takes at least 3 to 4 months to get back reviews from that journal, meaning referees will look at the paper and decide if it's worthy of publication. At least 3 to 4 months. If you do 3 to 4 months, if you get something back in 3 to 4 months, you should be happy. Biometrics is typically the fastest of all the other journals in getting stuff back, and that's 3 to 4 months. I've had papers where I've had to wait a year for it. So you get the paper back, and they'll never accept it. Well, rarely will they ever accept it immediately. They'll say, oh, these referees found some issues. If you want to resubmit, go ahead, but please fix these issues first. And so, you might be doing this for 3 to 4 months, fixing these issues. So then you submit it again. So now we're about at least 6 months down the line from when you first submitted. And they will review it. Again, they'll send it to the same referees, and it will take another at least 3 to 4 months for them to get back to you. And then they'll still usually, these referees will still often want some small revisions. And in the end, the whole publishing process, because then you have to resubmit again, will take at least a year from when you first submitted, not when you first started writing the paper, but when you first submitted until it's actually accepted. And then it's going to take a few months for it to actually come out online or in print. Now what STAT does is that they say on their website, and again I haven't tried this yet, they want to actually publish the paper within 30 days of submission. So you can see that's quite a bit different. And this is actually what happens in some other fields, is that you'll have that quick review and acceptance or rejection. And so how are they doing this? How are they really compressing the time frame for publication or acceptance? Well, typically a regular old statistics paper will have a length of 25 type pages, meaning like this. Not necessarily what you would see in a journal, but like type pages like this. And double spaced. 25 pages is usually a standard limit. Here for STAT, this journal, they have 10 pages. Also, no revisions. So, you submit it, it goes to referees, and those referees will essentially give an up or down vote. And then that's it. No revisions. I don't know what their acceptance rate is. I'm curious to see what it would be, but I have not seen it because it's still a fairly new journal. And so that's how they're doing it. The ISI doesn't have a monthly magazine anymore like AMSAT News. They used to. Some of these associations within the ISI, those still do. ISI's, the main office is located in the Netherlands. And they have some kind of weird ways of becoming members, to be honest. You can become, with the ASA, all you have to do is you fill out the form and you submit it. And voila, you are a member of the ASA. You can put that on your CV. Here with the ISI, about 15 years or so ago, they implemented a policy where you could become a member like that. And those are called regular members. Before that, and still now, they have what are called elected members, where you basically have to have somebody to vouch for you who's already a member, saying, yes, you're good. You can become a member. Anyway, so those are the two biggest statistical professional societies outside the ASA. Real briefly, let's talk about a few other ones that exist. The Institute of Mathematical Statistics, the IMS. I used to be a member of that, and this has been really more focused on mathematical theory behind statistics. They publish some very theoretical journals. They have approximately 3,800 members across the world. However, this is somewhat inflated because students can join for free. So, hey, if you want something to put on your CV, there you go. It's not going to cost you anything to join. So 1,300 of these 3,800 members are students. So you can see how that has really inflated things. The Royal Statistical Society, I guess you could say this is actually the second largest, but the Royal Statistical Society is focused more on the UK itself. And there's many other ones. I want to mention these two here. The International Indian Statistical Association, International Chinese Statistical Association. And I'm not an expert on those, but from what I see is that they appear to be associations focused on statisticians from India or China that are not necessarily living there now. So, obviously there's and we have a number of students like that here. They come from these countries, come to the United States, get educated, and then they end up staying here. Well, that's what I think these associations are mainly for. They have annual conferences. So the International Chinese Statistical Association, they're having a conference this summer in Chicago. The International Indian Statistical Association, they had a conference last September at Oregon State University, and then they alternate every other year. One year they'll be in the U.S., the next year they'll be in India for their conference, and next year they are in, sorry if I'm mispronouncing this, but Hyderabad, India. So hopefully I got that right. So anyway, so that's something of interest to look into. And there are also SAS and R user groups out there too that are kind of like professional societies. Any questions? Yeah.
This is with the publication process you were talking about.
Yes.
The stat. Is there a practice in stat departments where when people send their papers off for review, then they also put them up as working papers on their websites? Because in econ, the review process is even longer.
Oof.
And so people
I'm sorry to hear about that.
They put those up on their websites, sort of like, hey, I did this already.
Yeah.
Don't you try and submit something on top of me.
Very rarely do I see that. But it does occur. And I think the websites where they put them up are standard websites that other disciplines use. Because I know I recently came across one a few weeks ago like that. I can't remember what the website's called, but it doesn't happen very often. Any other questions? Yeah.
What kind of topics that can do stats, general, like?
All topics. Yeah. So obviously there are some journals like Biometric which focuses on, topics that would be statistical. You have some kind of applications in a biometry area, but stat is all topics. Okay, so next let's move on to this, talking about spring courses. So perhaps this might help you with this photocopy here. Okay. So what I've done is broken this up into if you're a master's student or if you are a PhD student right now. So this table here on page 1 comes from basically the first day of class. So next semester for MS students, you should register for 822 and 883. So just continuing on the same course line that you have been doing already this semester. But now you have an opportunity to take an elective. So you have some choices in what you can take. And here are the potential courses from the Department of Statistics that would be appropriate for first-year master's students. So there are 4 of them. And the first one is Stat 843, Next Generation Sequencing and Systems Biology. First of all, I don't have any experience in that area. But what I can tell you about it is, it's really looking at the statistical applications with regards to analyzing DNA and RNA data. And that's the most I can tell you about the statistics aspects of it. The instructor is Istvan Ladunga. He doesn't, how should I say? He's probably the least statistical of our statisticians that we have in our department. He doesn't have a statistics degree. He mentioned that during his seminar that he gave earlier in the semester. But what he focuses on is some, you could say, data science issues with respect to biology applications. And so that's somewhat what this course is getting at with respect to analyzing DNA and RNA data. It has an undergraduate cross-listing, so there will be some undergraduates in that course as well. So there might, he's actually, anytime that occurs, you are required as a professor to give to differentiate between what an undergraduate needs to do well in the course versus what a graduate student needs to do well in that course. It might be just as simple as a different grading scale, or it might be an extra project that a graduate student does. Typically in the past we have not had a lot of stat majors take this course every semester, but we do have a few, you could say, who do take this course. As with this course or any course that you're interested in registering for, talk to the instructor first about it. That's how you're going to be able to find out a better idea about it. So if what I say right now interests you, talk to Ladunga some more about his course. He doesn't have a course website for it, but from what I've found is that he does have a syllabus online from teaching in the past. Okay, the other course is Stat 874, Non-Parametric Statistics. This course actually hasn't been offered for a while here, which is too bad, because I had the course when I was an undergraduate master's student. I really, really liked it because it gets away from the typical parametric inference methods that we talk about. Like, I assume Y has a normal distribution. Well, you're not going to do that here. You're going to get away. You're going to get away from that. And the person who's teaching this is Yumo Chu, and he's taken a little bit of a different approach to teaching this course than, at least when it has been offered in the past, how it's been taught. Very frequently, you'll notice that courses that are in the 870 sequence are applied courses because it serves the needs of both stat majors and non-stat majors. When I communicated with them about the 874 course last week, this is a direct quote from one of his emails. The course will be theoretically based. What that means is that there's going to be probably and again, you should talk to him if this course interests you. It would probably be a lot less computer emphasis to it. Probably somewhat structured to what you see in 882. Do you use the computer much in that course? Okay, that's what I would expect for saying it's a theoretically based course. It would be structured more like that, which for some students you like, some other students may not like. His prerequisite is Stat 882, which is different from what is actually listed in the course catalog for this university. For the university, it's Stat 801, which is you have at least one stat course sometime in your history. Very low prerequisite. He's making 882. Now that he has told me this, I have actually told him that you need to make sure that it's clear to the students, and that's one reason why I'm talking to you about this, that is the prerequisite. And in fact, this is potentially a problem for the non-stat students who might be interested in taking this course, because they won't know, because they're not in Alpha Seminar right now, that 882 is the prerequisite, which is different from what's stated. So because of that, something's going to be done in terms of how to register for the course. It might be like we might make the course you can only register it with a permission number, so that students have to ask the instructor for the permission number, and that's when they're told that 882 is the prerequisite. Or what I've suggested to them is actually move it to a topics course number, like 892 or 992. So what are the topics in the course? Kernel estimation for density functions. A very simple idea of what that means is that, let's say you have a histogram. Okay, there's my histogram. And you've done many times before, you've put like a little normal distribution curve on top of it, okay? Well, suppose you want to estimate what that curve is without going into a parametric case. So that would be kernel density estimation. Okay? And that's an interesting topic. Kernel estimation for regression or local linear regression. What does he mean by that? Well, let's say that I have this scatter plot of x versus y, and I want to estimate a regression model to those points. Well, one particular method to estimate a model is use what's called a Lois method, where instead of just fitting a straight line to this, instead what you can do, hopefully I can erase that, there we go. Instead what you can do is this. Look at a neighborhood of points. And let's say you want to find, well, what's the estimate for that point there? So what you could do is actually estimate a linear regression model to that neighborhood of points, and based upon what the y-hat is that you get from that regular old linear regression model, that's going to be your y-hat for this. Then maybe form another window of points or neighborhood of points. Fit a regular old linear regression model to that, and if I want to get, let's say, the estimate, the y-hat for that, I use that particular model. So you can see you're using lots of different local regression models to come up with y-hats. And so if you were to actually then plot all those y-hats and try to connect the y-hats with a line, it's not going to be one straight line throughout the entire plot. Instead, it's going to kind of be bouncing up and down. It's trying to get at that true relationship that may not necessarily be linear or quadratic or something like that. So it gives you more freedom to getting a better estimate. If you want to know more about that, you can take a look at Chapter 11 of my Stat 870 notes that are available online when I talk about Lois regression. Also, some bootstrap theories. The bootstrap provides a nice way, in the simplest sense, the bootstrap provides a nice way to estimate probability distributions. And it's a very computer-intensive method. So that's why I'm wondering, well, how can you get away from maybe potentially using a computer in this class? Towards the end of, you're using Cassell and Berger for 882? Towards the end of that book, you'll see some basic bootstrap stuff in that. I've actually taught a whole course on the bootstrap, and it's available through chrisbiller.com if you want to see it. And then lastly, he may do some rank-based tests. This is the traditional topic that a non-parametrics class is usually centered around. And what that means is this. Let's say that you are, let me find a blank space here. You're interested in the simple hypothesis test of mu1 minus mu2 is equal to 0. So you have samples from two different populations. Okay? And you could do a simple t-test to test the hypotheses. Well, that again relies on certain underlying parametric assumptions, such as normality for your two populations. Instead, what you could do is this. Suppose you take your two samples, you combine them together. Okay, so now you have, let's say, one sample. I mean, eventually you'll be able to take them apart. But let's say you combine them together. And you replace the actual observations with their ranks. So, for example, let's say that population number 1 has typically lower values than population number 2. So you would expect population number 1 to have lower ranks than population number 2. And then using the ranks now you can separate out your data again. Using that ranks, you can do a variety of different hypothesis tests that do not necessarily rely on an underlying normal distribution approximation anymore. So there are tests like the Wilcoxon rank sum test, for example. So that's what that course is going to be about. Again, talk to UMO some more if you're interested. Then there's my course, Stat 875. You can go to my course website from when I've taught it in the past to see what it's all about. I use a blended learning teaching approach in that course right now. What that basically means is that I have recorded all my lectures from teaching the course the usual way, you could say, and I recorded them in the past. And so what I have you do is I have you watch basically 2 lectures on video each week, and then we meet once a week to go over stuff that maybe wasn't clear in those videos, to answer any questions that you may have, to talk about projects or assignments that we will have, to talk about tests coming up, and also for me to add some additional material, or I should say additional explanations on stuff that I know that students typically have problems with. And so that's how I approach that particular course. We focus on the application of statistics. So, the prerequisite for that course is Stat 801, with a recommendation that you had some further regression experience. We use R exclusively, and there is a little bit of overlap between the topics in 821 and 822. So for those of you who are taking 821 right now, have you talked about something called logistic regression in that course? Not yet? Okay. Then you will in 822. But the way that Wald approaches it is from talking more about the theory. Like, I know a common problem that he gives as a homework is he will actually have you program in, without, let's say, using proc glimix or any proc in SAS, he'll actually have you program in the actual algorithm that's needed, like a Newton-Raphson method, to actually estimate a model. Where in my class, I don't do that. We're focused on the application, and we use R, he will use SAS. And so we talk about some of the same models, but there's a number of models that are different as well. At least in the past, when I've talked to students who've taken Walt's, although this is 821 and 822, 822 is somewhat based upon our old Stat 971. And I've talked to students in the past about, okay, well, is there too much overlap? Or, is it really worthwhile to take my class, even after taking his class? And they've always said yes. And because of my focus on the application, also my focus on R. You are welcome to talk to other students in our department and see what their impression is too. And that's always good with any class. Talk to other students, see what they've liked. And so this course is based upon my book that I wrote for the course. And then lastly, there's a Stat 892 course called Computing for Big Data and Statistics. So you might, and this is taught by Ledunga as well, and you might remember him giving a seminar at the beginning of the semester about it. That's what this course is. What I was surprised to find out when I was looking at all the courses available online is it's only 2 credit hours. So for some students who need 9 credit hours, especially due to their international status, this might cause an issue. But for some students though, let's say that you're a domestic student and you're looking for that 36 hours to get the master's degree and then leave. And let's say you're a TA. Well, TAs this semester are taking 10 credit hours. So in the end, it will average out to 9 credit hours if you were to take this course plus the 2 other ones in the spring, and just have 8 credit hours. So last semester I was on a committee that was looking at revisions to all our elective courses. So I was on the committee that looked at the required courses, and I was on the committee organizing the elective courses. And one of the courses that we proposed was some kind of data science course that talked about the stuff in data science that are not statistics. And just from Ledunga's seminar, I think he's essentially doing that. So, like how to work with big data in terms of not analyzing it, but how to work with it. And so if you remember in a seminar, he talked about like working with Linux, for example. So anyway, I won't get into it too much more because there was already a seminar on it this semester. And feel free to talk to him more about it. So let's talk about courses for PhD students. So if you're a new PhD student, you're basically in a similar situation here. You have 2 required courses that you need to take next spring. And then you have room for an elective. So what can you do for an elective? Obviously, any of the courses that we just discussed, those are possibilities. Also, some professors allow students to take an 800 level course as Stat 992, provided they complete extra work. So, for example, maybe, I don't know if UMO would do this, he would let a student register for the course not as 874 but 992, and that student will have to do some extra work to get 992 credit for it. Why is that important? Well, PhD students are required to take, if I remember right, off the top of my head, 2 elective 900 level courses. And so sometimes PhD students will avoid taking 800 level courses because of that, which is a shame. And so anyway, so you could potentially get the 900 level credit. Just note that I personally don't like that in terms of allowing a student to take an 800 level courses at a 900 level. I don't think it's, to be honest, I don't think it's, at least from what I've seen from other professors, I don't think it's really 900 level worthy. But that's just me. The reason why I say that is because I wouldn't let a student take 875 for 900 level credit. Another good course to have is Advanced Experimental Design. So much of statistics is based upon experimental design. Understanding, completely randomized design, a randomized complete block design, a split plot, all that stuff, a Latin square, all that stuff. And I know I have found it to be helpful myself. Taking a second semester of experimental design can be helpful. And so this is a good class to have. There's also another PhD level course out there, but I don't think anybody in here would have the necessary background for it yet. Okay. Are there any questions about courses that are available in our department before we move on to potential courses that may interest you from other departments? Yes?
Also, that the categorical data analysis, which textbook would you use?
Mine.
Oh, okay, just that RI.
Well, my book.
Okay, thank you.
Any other questions? Yes?
Yeah. Like how often in your life do you apply non-biometric statistics?
Okay, my life. You have to realize my life is in academics, okay, and I don't have a consulting appointment. I have found the Bootstrap to be extremely useful. I have used it many times to do my research. And I see the Bootstrap as becoming more and more prevalent in society, you could say, statistical society or non-statistical society, because it provides we have the computing power now to get around what was in the past. You needed to have a very high mathematical background to understand it. Okay, I can derive the t-distribution through using a ratio of a standard normal to a chi-squared divided by its degrees of freedom, square root of chi-squared. The Bootstrap provides ways to say, forget it. Just apply this computer algorithm to estimate that distribution. And so the Bootstrap stuff I would find extremely useful. Now, as I said before, I've taught a whole semester of the Bootstrap. I taught about 4 times here. It was originally listed as Stat 950. It was an every other year course for PhD students. Since then, in our new revisions, I propose, instead of having a whole semester of it, that for an elective course, how about we put a chunk of that into a new computational statistics course and label this now as Stat 950. So computational statistics, I would expect that to be offered next academic year because it is a required PhD course. But it's taught at a level that second-year master students once you got that 883 done, you can definitely take it. So, I'm talking a lot about the bootstrap here, but if the bootstrap stuff interests you, there are other opportunities to get it. Now, at least now I don't have a whole lot of experience with the kernel density estimation. I've had a little bit more experience with the regression stuff. My main areas of what I've used non-parametrics for is this right here. So there are, for example, stuff called permutation tests, which again are based upon essentially using ranks, but they use computer algorithms, you could say, to basically what you could say is actually do a sampling process for you, to mimic a sampling process. That's what the bootstrap does too. And so those can be very useful. I have seen them applied, even like in my internships that I've had. Any other questions? Okay, the key is talk to a professor. Now we are running it short on time. And what I've done is late last night after the debate, I went through the course bulletin, or not course bulletin, but the schedule of courses that are being offered. And I focus on specific departments where I know our students have taken classes from in the past, and also departments that I know have some statistics-related courses. Okay? And so what I've done is actually write them all out. I encourage you to take a look at the course descriptions. At the very bottom of page 7, I give you the direct link to the course catalog that will take you to the course descriptions. Real briefly, which ones do I think that would be most of interest to students? The Computer Science 970, Educational Psychology 971, Math 828, and UNMC's Biostatistics 835. Okay. I'm going to try to quickly talk about those 4. Note that there's a few that have lines through them. That's because you may see them and think, oh, that might be of interest. And then I will tell you now, I wouldn't approve that as a course that you could take outside the department because it's too low of a level. So let's talk about this design of medical health studies. Notice it's an online course, so even though it's offered at UNMC, there probably wouldn't be travel involved. This is a course that Michelle Quinlan mentioned when she was giving her presentation in our class that she said she really liked. Now, on the surface, I think this could be an excellent course, especially for those who are interested in the pharmaceutical industry, because you're talking about how to design medical health studies. Well, like clinical trials. So you might think it is like a clinical trials course. And at least from my impression from talking to students who've taken it, it's not necessarily like that. And I've had a number of students give negative evaluations of it. Perhaps it was just maybe a bad professor. But I've had a number of students come away disappointed. Now, obviously for Michelle, she did not. So if something like this interests you, and I could definitely see this could interest a lot of students because this could really help you find jobs, like even internships in the pharmaceutical industry. Definitely talk to the instructor about it before you register for the course. Principles of Operations Research. That looks like a good course. Note that this is cross-listed as an undergrad course. If I didn't, I sometimes wonder in my career I had basically Math Stat 1 and 2 as a junior as an undergrad, and that's where I found out I really love statistics. As a senior, I took a linear programming course, which was part of operations research. I really liked that course too, and I wonder sometimes if I would have took that during my junior year, if I would have went into operations research. But anyway, what is operations research for those of you who maybe don't know? A typical example is, let's say, airline scheduling. Let's say you work for an airline, and this airline has a fixed number of airports that they that they have their airplanes at. They have a fixed number of airplanes. They have a fixed timetable. What's the optimal way to assign the airlines or the airplanes to the locations and get everything working nicely? That would be an operations research problem. Very, very interesting. The key is optimization. In statistics, we do a lot of optimization too. Like maximum likelihood estimation, that's an optimization problem. So I know from my linear programming class that I took as a senior, that helped me see maximum likelihood estimation in a different light than I know some other students who didn't have that background when I was taking like Stat 883. Structural equation modeling, so you're constructing basically what are like regression models. The key is that you have a particular, you could say, response that's unobservable, or often referred to as latent. So let's say you have a number of explanatory variables and you want to relate them to intelligence level. What is an intelligence level for people? Well, how do you measure it? Well, you can't measure it exactly. It's not like measuring someone's height. And so intelligence is essentially a latent variable. Well, how do you model that kind of stuff? And so if you've had factor analysis, maybe in another course, structural equation modeling is somewhat related to that. If you have not had factor analysis in another course before coming here, you may not have a sufficient background to take this course. And lastly, pattern recognition. Two quick examples. For those of you who are in my Stat 850 class, you know about my place kicking data set, where place kicking football is either a success or failure. And I have a number of explanatory variables that I would like to relate to it to try to estimate the probability of success. Suppose instead all I want to do is simply determine, is this place kick going to be a success or failure? So I'm just simply predicting the classification only, not necessarily the probability of success. That will be a topic. Also, a classic data set in statistics is what I refer to as the goblet data. So a number of years ago there was some archaeological digs being done in Thailand, and they came across these goblets, and they wanted a way to somehow classify these goblets, because you know some goblets maybe are used for drinking purposes, or other goblets might be used for other purposes, and they wanted somehow to find like goblets and classify them together. The key, though, is that they don't necessarily know what an appropriate classification would be. Should there be 2 classifications? 3? 4? They don't know that beforehand. They don't know. Am I going to classify small goblets here and big goblets there, or whatever? And so you're trying to find patterns. Pattern recognition. Okay? Very frequently, the topics that you would see in that kind of a course are talked about in a multivariate methods course, like our Stat 873 here. Like if you've heard of discriminant analysis. That's essentially a pattern what computer science would call a pattern recognition method. But obviously they're going to be talking about ones that are not necessarily statistically related. There's probably going to be a little bit of overlap between what you would have in 823, where you will talk about some of these multivariate methods topics, but there shouldn't be too much overlap. And this is a hot field to get into. Just be careful about the prerequisites that's listed for it. The stat prerequisite is really low. The math prerequisite is really low. It's like matrix algebra, but there is a computer science component to it, and so you have to be careful about that and talk to the instructor. You know, while a prerequisite is listed, sometimes that prerequisite is there not necessarily because you're going to be using that material directly in the course, but rather than it's to make sure that you are, let's say, at a mature enough level to take the course. And oftentimes those kinds of prerequisites, the faculty members say, oh, you're fine, you're a graduate student, you're doing a lot of stuff that's somewhat related, you'll be fine. So, anyway, I apologize for going over there. Are there any questions? Yes?
This is an odd question. If I want to ask this, can I take a 900?
Yes, yes you can. Yeah. You know, there isn't a set guideline of what 800 and 900 level means. What I am hoping as graduate chair to move towards, though, in our department is to try to make 800 mainly for master's students, 900 mainly for PhD students, because I think it's helpful to do that.